Welcome to 61D, the course where we teach you modern full-stack web development. My name is Aiden, and today we're going to be covering the basics of React. We're going to start off by giving a little bit of a conceptual overview and background on what React is and why you might want to use it. Then we're going to give you a crash course on some very basic HTML before talking about the structure of a React project, how we can break down our project into individual components, and how we can use JSX, which is just a specific way of writing JavaScript, to add interactivity to our application. And we'll cover more on interactivity and React state in the next lecture. Over the next two lectures, we'll use a dice roller application to demonstrate the principles of programming with React. You'll be able to create a die. So if I clear my existing one, I can create die1, add die, and then it can have any number of sides. So I could have one 6-sided die and one 20-sided die. Oops. D20, add die, and then I can roll my die. So in this case, I rolled my 20-sided die and got a value of 8. Roll it again, get a value of 5. Could add another D20, so say D22, which could have 20 sides. Add die, and then I can roll both of them, get the total. So the total is 15 out of a max of 40. First die rolled 4, second die rolled 11. This is similar to something. This is essentially recreating the functionality of this rolladie.net website where you can add multiple die. So for instance, I could add 2 D20 die and roll them like so. So you will create your own version of it. Also important to note that we will not be properly styling this website. We'll cover CSS styling in lectures 5 and 6, but for now we're just covering how you can lay out all the individual parts of a website and how you can make it interactive. Today we'll just be creating this static display, and then in lecture number 4 we will add all the interactivity around adding die, adding dice, removing dice, rolling dice, clearing dice, and even persisting the state between refreshes. So if I have a couple rolls and refresh the page, all of our info will still be there. The reason to use React is that it allows us to break our website down into what are called components, which you can just think of as the core building blocks of a website. Anything can be a component, and you can create more complicated components out of smaller components. This is just the example from the React homepage. Right? You can see how we can define a little video card, which can be created out of our thumbnail, our information about the video itself, and then an interactive little like button. Then, once we take that building block, we can use data to render a list of videos, and we can reuse that building block 3 times, right? So here we have videos that we take in. This could be fetched from a server or something like that. We use JavaScript code right in the same spot as our HTML markup to reason about how we should operate. So for instance, this JavaScript code checks whether or not video should be singular or plural. So you can say 3 videos, but it would say 1 video. And then when you have that, you can then make your web page interactive, right? So we showed the little heart logo you can turn on and off, but you can also power something like a search. So I could search React and find only the videos having to do with React. There's a lot more background and context you need to fully understand React, However, the best way to learn it is just to dive right in and see it used in practice. And then we can explain some of the conceptual backgrounds as we actually start using stuff. So there's no starter code for this assignment. We will release, well, there's no starter code for this lecture. I will have the solution code in the description of the next video. We're going to start instead from a completely blank project. So what we're going to do to create a React project is we're going to say bun create Vite, V-I-T-E, at latest. This is going to bring up our little CLI to create the project. We can name it whatever you want. In this case, I'm going to call it React Dice Roll. Then we need to select what framework we're using. In this case, it is React. We are going to select TypeScript plus SWC. And there we go. So we can follow this. We can cd into React Dice Roll and then open it up in VSCode. Before we actually can run this project, there's a few important files that we need to understand. The first one is the package.json file. This is going to exist in any React project and basically any Node.js project. So if you're just running a backend, if you're running any other framework, something like Vue, you're going to have a package.json. So what this does is it defines what are all of the dependencies required for you to run this JavaScript project. So in this case, in here, we have defined React and React DOM as dependencies. What that means is we can't run the project without having those dependencies installed within the project. So to install the needed dependencies, we can just run bun install. And what you'll notice is it created a node_modules folder. This is the actual code, all of the code that you need to make React run, right? Everything that is going to be happening under the hood, it's all defined under here. But this is a very large file, right? So it doesn't necessarily make sense to include the node modules specifically in your project when you push them up to GitHub. So instead, what we do is we just define what the dependencies are so that anytime you need to initialize a new project, right? Let's say we accidentally deleted this, you can just run bun install again and have your project configured. There are also specific dev dependencies you can specify, and that is anything that is not going to exist when your project is running, but only exist in your development environment. So for an example, TypeScript doesn't actually run in the browser. It only exists from a developer perspective. So therefore, we need it as a dev dependency, but not an actual dependency. Final thing within here is we have certain scripts that are predefined that we can run for the project. In this case, we're going to worry about the dev script, which will start a project. To run any of these scripts, all you need to do is say bun and then the name of the script. So in this case, bun dev, and it will start our project, which we can open up. So as you can see, we have our static website and a little bit of built-in interactivity, a little counter. And if we want to see a change, we can edit something in app.tsx. So we can go to source app.tsx, and we could, instead of saying Vite plus React, say hello world, save it. It's going to hot reload and update right there. You'll notice also that the change we made, right, this little change, did not completely reset the whole page the same way that a refresh would, right? Our count was persisted. this is the key idea behind React, not just in the development environment, but also in the entire sort of built React project. React will identify, hey, where is a specific change occurring? And what subset of the entire page do I need to re-render to properly show that change, right? So in this case, clicking this button is only going to re-render this button. It's not going to re-render this text or either of these images. Let's take a look at the app.tsx file. It's the main file that we have currently that contains all the information about our project. You can see that what it is doing is it is tying together the three main pieces which create a website. We have our HTML, which are all of these individual tags. We've got div, a, image, etc. We have our CSS, which is defined in a separate file for now. This is providing all of the styling, which currently exists. So for instance, the thing that is making our background the certain gray color, all of the nice spacing and center alignment is defined with the CSS. And also we have JavaScript, which is being executed, right? This function is a JavaScript arrow function, which is storing the count and incrementing it. For instance, we could make this multiply by 2 instead. And then we go from 2, 4, 8, 16, etc. Right? So that is the idea behind React. In this one sort of contained environment, we can very easily use all those building blocks together and put it into a component, a single section of isolated code that has everything it needs, and then use that component somewhere else. So for instance, this app is technically not used in this file. We export it and then import it into our main.tsx, where we run it from higher up within the project. And then the actual entry point for our project is our index.html file, which has certain metadata about the page. But the main thing that it does is it has this script tag which runs main.tsx, which once it's built will be a JavaScript file, so we can run JavaScript within this HTML. Speaking of HTML, let's cover some of the most important tags which you will be using very, very frequently. To start, we can look at just what is used within this page. The most basic thing you might include is some text. For instance, we have hello world, which we could move to the top. Hello world is an H1, which just means that it is a header. You can also do H2, 3, 4, 5, and 6. So let's show you the difference between size in an H1 and an H2. So that's our big H1, our small H2. Also, you'll notice that the closing tag is automatically getting edited as I edit the opening tag. That is the result of an extension that I have installed. If you want to check out our recommended extensions for the course, I will have them all linked down below. So that's basic header text. You can also have a P tag, which is paragraph text. So small body paragraph text, like so. And then if you want to have more specialized text, you can do other tags such as this code tag, which is showing you this nice monospace code font, which we can show an example of. Could say console.log hello. like so. All HTML tags have to have an opening tag and a closing tag. So in this case, we have our h1 opens up, and then the body of the tag, and then a slash before the closing tag. You can then nest tags within those, you can nest tags within tags. Our whole thing is nested. So for instance, we can have this code tag nested within our paragraph tag, as long as you have the opening and closing of the nested tag before the closing of the parent tag. There's also certain situations where you can have just a single tag that is both the opening tag and closing tag in one. So for instance, if you wanted a paragraph break, so let's say we wanted a break, this is opening break, closing break, right? Such that we put console.log hello on the same line. However, if we don't need to nest any content within this break, we can instead just write it like so, where we have break and then this closing slash at the end, such that this acts as both the opening tag and the closing tag. Next up, we have links and images. Links are created using this a tag. You say a, and then the prop you have to pass is href, which says where the link is going to, and then the destination. So for instance, if we click on this Vite logo, it brings us to the Vite docs. Saying target equals underscore blank will open it in a new tab. So if we were to delete that and try this again, it would redirect us directly instead of opening in a new tab. Images have both, they have the img tag. Normally they are self-contained. So like we talked about this break tag, because you don't necessarily wrap content within an image. The things you need are an image source. This can either be an image you have locally in your project. So in this case, we have this vite.svg. I think it's in assets. Is it in assets? Where is it? Vite.svg. Okay, so this is an SVG, but for example, React is also an SVG. So it's programmatic, but you can imagine we could have a PNG file. But regardless, this is local in our project. Or you could also have a URL. So for instance, if we have an image URL like this guy, then we could paste that in and we'd still have our Vite image that way. The other important thing to have is an alt text, which displays in case this URL can't load for any reason. So if there was a typo, get rid of the D, then it would show this alt text. The alt text is also important for screen readers and accessibility purposes. And there's many other things we'll cover throughout today's lecture, which are there so that it's easier for screen readers and other tools to be able to tell what is on a website, so that you can have a very accessible web that can be usable by everybody. Once we have some content that we want to display, so for example, we've got our headers and then the images, we need to find ways to group them. So as you can already see, the main tag that you use to just wrap a group of other tags is a div tag, which is just a division within a web page. In this case, we are grouping the images so that they can render separately on their own line horizontally, and then afterwards this button will render. If we were to get rid of the div, then get rid of that div, and then maybe also get rid of that div. Right, then these three would not be segmented. They would just kind of all be in a line. It's also important to know that although the div tag is the most commonly used tag for generally separating out sections of your code. There's many other tags which accomplish the same purpose and which also have a little bit more description of what is the thing you're actually grouping. So for instance, I could say that I'm going to have this be my header and then wrap my H1 and H3 in that. And the rest could be my body. Functionally, this does not provide any difference between using like a header tag versus a div tag. However, as we mentioned, for one, it makes your website more accessible so that screen readers and other things can better process it. Two, it's better for search engine optimization so that as Google is crawling your website, it can better tell what it is looking at and how it is generally organized. And three, it's also just better for working with other developers because they can look at your code and immediately tell how is this segmented. There's many other tags that are like this, and the term that we use to describe these tags, which don't necessarily have functional differences, are called semantic tags, or the process of using them is called semantic HTML. Final two tags we're going to cover are button tags and input tags. The button tag takes what is called an event handler. When some event takes place, so in this instance on click, you define some JavaScript action which says what you want to do. In this case, on click, we want to double the value of count, and then every time it is clicked, that action will take place. Buttons also normally nest and wrap some content that is normally going to be just the text of the button that says what the button is going to do. Final tag is an input tag. So we can say input. And normally here you don't wrap this. You have it just as an input like that. You can set a placeholder text. So we'll say hello. And the other important thing to do is define an input type. So your type can be any of these, right? You could say that it is just a standard text input. And if we do that, look over here, the CSS is all a little messed up. We can input text. You can also do a number input, which prevents you from typing in text, and you can only type in numbers. Along with the other few interesting ones, you can do a date input, which will let you have a little date picker, and a file input, which lets you actually upload a file. Those are little clips of the video. Finally, you can add a label for your input. So in this case, we want to say what the content of the label is. So we would say like that, and we'll say file input, like so. But we also need to directly associate this label with this input, again, for the purposes of things like screen readers and SEO and all of that. So for that, simplest thing to do is just give this input an ID property. So we can say ID equals, we could say profile upload or profile pic upload. And then here we would just say that this is HTML4 our profile pic upload. Like so. So again, you can't really see any difference there, but it is important to directly associate the label with your input. With that basic overview done, we are now ready to actually dive into building out the project, building out our dice roller. To get started, as a few house cleaning things, why don't we just delete all of this in our app.css file, except for this root tag, because that makes it look a little nicer. We could also set margin to 2 just so things get spaced. We can delete the index.css file, delete the ESLint config file. I'll talk about why in a second, and go from there. Also within here, we can delete the Vite logo, React logo, just make this one div tag and delete everything else in here. And now we are ready to start. So let's take a look at the finished project and think about what are the individual building blocks of this web page, because that's the real way that it makes sense to think within React. What are the building blocks that are repeated? What are the individual functional units? And how can we generally just organize things in a way that makes sense? So right off the bat, we have, a little bit of a sort of header area, and then the rest of it is more of the actual results. So you can think of it in terms of the dice roller and the roll results. Well, more like the place where we're going to create the dice and then where we're going to view the results of our dice roll. If we're breaking down the dice rolling even further, we can see that first off, we have some inputs for adding dice. Then we have a place where we're actually going to render a list of dice. So we have this exact same component repeated twice, just with different data for each dice. Finally, for the actual rolls, again, we have this component which is repeated for every single roll. So what we're going to do is we're going to break this down into 3 components. We're going to do the die input, the die view, and the results view. So let's scaffold this project. Also make sure we delete that so we don't get an error within main.tsx. It doesn't necessarily make sense to put these components anywhere. Typically, you want to create a specific components folder, which will house your various different components. You can then greater subdivide it into smaller folders if you have lots of related components. But if there's anything that you're going to be reusing, you can make a folder for it. So then we had our 3 different things we were going to create. We are going to create the die display, and we're going to say .tsx. We need to create the die input.tsx, and we need to create the die display.tsx. I already did die display. Need to create die result. Die result. That's what I meant. Or you could even call it roll result.tsx, right? Because the result of dice is the roll. And then the other sort of headers and whatnot, we can probably just have within the app.tsx file. So now let's create our first React component. A React component has a couple rules that it has to follow, which are demonstrated in our app.tsx file already. First off is it has to have a capital letter. The reason being that helps React distinguish between what should be a component and what is a built-in HTML tag. Moreover, what it returns has to be a single element, which has all of the children wrapped in it. For instance, this is just a single div, but as we saw earlier, all of the content of the component was wrapped from this single parent tag. If I was to try and put a paragraph up here, we would get an error. Everything has to be nested under a single parent component. Most of the time, that's just a parent div. So let's try it. Let's go to DieInput, and we can declare a function. We can say export const DieInput. For now, we aren't going to pass anything into it. And hopefully, this syntax should look pretty similar, right? It is just the arrow syntax for a JavaScript function. Now we can just return an h1 tag and say input die. Now, as you see, we use this keyword export. What that means is that this component can be then imported into a different file. You can also export other things besides React components. If I had some kind of constant or some kind of variable that I wanted to use other places, I could also export that. But for now, we're just exporting this die input. Then in our app.tsx, we can import that component. We say import die input. Here, our sort of IntelliSense is filling it out for us, but I'm just going to show you how you could do that if you weren't using it or if it wasn't working correctly. So DieInput is the name of the component. Then you say from, and then where within your project it is coming from. You can say // to escape your current folder. So here we're inside the source folder. If we want to escape the folder and go up a level, we would use //. And as you can see, it's showing us all of the things that are above the source folder. If we want to stay within the source folder, we can say just // and then we see all of the possibilities within the source folder, // components / DieInput, like so. Then we can render that DieInput. And again, we could have it as an opening tag and a closing tag, but since we aren't passing anything to it, we can just have it be one self-contained tag. Restart the project, and then once we have it running, we can see we have our component that we used up here, and then the rest of our project, which we have below it, just like so. One other quick point with imports is there are actually two types of imports you can do in React and JavaScript generally. You can do default imports and normal imports. If we look at the current file we're in, we say export default app, and then when we import it in main.tsx, we just have to say import app. However, if you don't have a default export, in this case, we just say that we're exporting the DieInput, but it's not the default import. Sorry, it's not the default export. Then when you import it, you have to use this curly brackets notation because you could have multiple exports from the same file. So if we were to, for example, export const hello would just be some string. Then we could import DieInput and also import the string hello as well. You can only have one default export per file. And generally, unless you are importing the default import from some library, when you're just writing your own components, you normally don't want to use default exports because then every single time you're trying to import something, you have to consciously think, oh, is this the default export or is this a normal export? So it's normally better to just stick to normal exports. In addition to scaffolding our components, we should also scaffold the types that we're going to need for this project. We're going to reuse the same types that we're going to use to describe our data in multiple different places. So it makes sense to centralize them unless it's a type that we're only going to use in one file. To do this, you can create a folder, and in this case, we'll say dicetypes.ts. And then if you, for example, had a more complicated project, you could, organize your types however you think makes sense. If we look back at the final project and what the information we need to represent a die, all we need is a name and a number of sides. So, for example, the name. And then after we roll it, we have the name, number of sides, and name, number of sides, and the actual result of the roll. So if you want to try this yourself, you can try defining those two types, a die type and a die result type, and I will do it in 1 second. So for the die type, all you need to do is say name is going to be a string and sides is going to be a number. Oops. Then the die result, we want to extend the die type. So die result equals die and result, which will be a number. Now we can export both of these types, which we will use later. Then when we actually want to import a specific type, you can be a little more explicit that the thing you're importing is only going to be a type and is not a value, such that when your code is getting compiled and outputted, that import statement can kind of just be ignored. So we could say import type die from types dice types. Final super quick thing is create a temporary data.ts file, which will represent data that the user would input. We will be creating the actual interactivity in the next lecture, so we just need some sample data for this lecture. You can either create something like this, create a couple die and a couple die results, or link in the description, you can just copy and paste this gist like so, and you are now ready to go. Now let's start actually building out these three main components: our input, our display, and our roll result display. If we look back to the finished project, we also might need to add some headings, some buttons throughout. We're basically just going to go top to bottom, implementing what we have so far, except just use static data for now instead of the data that the user will input at the end. So first thing we need to do is go back, and we need our nice header. For that, we want to do an h1, and we can just say we have our dice roller, and we can delete this other stuff, but maybe we can put a comment saying what else we're going to have. We are first going to have our dice input. We also need our roll button. Roll button. The way that I created that comment is you do either control or command and then backslash, like so. So roll button. We are also going to need our dice display, or I guess die display is the name of the component. Die display, and then we're going to need our bottom header is just going to, we'll use a h2, say rolls, and then we will have our rolls result. So if we look back, we've got dice roller, we're going to have the input, and then the rolls. So let's start off just doing this input. We don't need to import or take in, for lack of a better word, any data. We're just going to have to create the inputs and create the button, and then later we will make it interactive. So first, we're going to wrap it in a div. Then you can give this a try yourself, or I will show you the solution in 1 second of how we can recreate just this top line. So first off is we need a label and a corresponding input. The input we want to give some kind of ID. So in this case, we can say name input, and then the label we will say is for that input. So we'll say HTML4 equals name input, and then say that we have a name. We want to say that this is explicitly of input type text. And then we can copy and paste this for our sides. Except instead of saying text, we need it to be a number. Lastly, we can add our button. The button is going to say add die. And we can check it out. There we go. It's a little messed up on the CSS, but don't worry about that. If you want to make the spacing a little bit nicer, all you need to do is add this global margin 2 points. So asterisk, curly brackets open, margin 2 pixels in app.css. Now there's a couple other finishing touches we want to add here. First off is we want to make sure that we have some kind of limit on the number of sides. So it doesn't make sense to have a negative number of sides on a die. And if you have a one-sided die, then that doesn't really do you any good. So what we can do is say min equals 2. And then this input will not let us go below 2. If you try to do like negative and you click out, it'll revert back to 2. We can also add a placeholder for a name to give you a little bit of just inspiration for what you might call your name. So we could say placeholder, sorry, that's not the label. We need on the actual input. Placeholder equals, for example, D20 for like a D20 die. And there we go. The other thing, just to get ready for once we actually have some kind of action, is we can add our onClick event handler for the button. So we could say onClick, and then within this, we need to pass in a function. We can either do some specifically defined function, or most of the time we just do an inline anonymous arrow function. So we can say alert added die, and then when we click on it, we just get a little browser alert like so. If we look back over at our sort of completed dice roller, we can see that we have about a third of it done. We have our first die input created. Now we need our dice display, and then at the end, we're going to do our roll display. The dice display is going to be a little bit more complicated because it's not going to be static, right? No matter how many dice we have, no matter how many rolls we have, the dice input is going to look the same no matter what. There's just going to be one input. We can have some placeholder, but it's just going to be the same. For our dice display, we need to be able to pass some data into the display. You can imagine that if our data is stored at some other point in our application, we need to be able to pass in an array of dice to then display in the dice display. To do this in a React component, you have to pass what are called props. You've already done a little bit of work with props, even if you haven't necessarily fully realized it yet. For example, passing in the function to our onClick handler in our button is essentially passing a prop. It's just instead of passing it to a React component, we're passing it to a native HTML component. Same with our input, saying that it has to have a minimum value of 2. It's some property which either controls what the component displays or how it behaves. So how would we implement this for our next component, the DieDisplay? Let's start off by just creating a component. So export const DieDisplay equals some component. And for now, we can just say return just a little p tag that says display, like so, that. And then in our app.tsx, we can import it, import DieDisplay, and showcase the DieDisplay. So, right, we have our little display like so. If we go back to our DieDisplay, you might have been thinking of this as some sort of new, unique concept that we're introducing of a React component. But in reality, it is kind of just a JavaScript function, except instead of returning some data we've already experienced, like returning a string or returning an array, we are returning HTML to be rendered in our front end. Or more specifically, we're returning JSX, but we'll talk about that in a second. So we can think of our function as taking in arguments. In React, these function arguments are called props. In this case, since we are displaying dice, we need to define the type of the arguments that it's going to take in. So what we can say is we can say type DieDisplay props is going to be an object, and in it we're going to have some dice which are going to be of our die type, which we can import type die from our types dice types. So we are going to have an array of die, which I guess maybe we should call it dice, but it's an array of individual die. Then we have to define the props that this function is going to take in. To do that, we have to say that we're going to get the dice property, and that this object is going to be of type DieDisplayProps. This syntax might be a little bit confusing, but it might be easier to think of it as just saying we are passing props, which are going to be of type DieDisplayProps, and then we could use them in here, right? So we could just say, console.log, props.dice or something like that. However, conventionally, we destructure the individual properties that we're going to use from the props. So in this case, we destructure the dice property. Then, if we want to actually use this JavaScript value within the markup that we're returning, we can do so by using curly braces. Anytime that you use curly braces within this markup you're returning, which is called JSX, it allows you to directly execute JavaScript within your JSX code. So in this case, the only thing that we're going to be executing is displaying the dice. We haven't talked about how we're going to render all of them. So perhaps for now, we can just say json.stringify dice, which will convert our array of dice into a JSON string that we can display. Then, if we go back to our app.tsx, we have to pass in the props to our DieDisplay. So to do this, if we remember what the name of the props are, we have dice equals an array, and they're an array of die objects, which have a name property. So we'll say die1, and a size property, which we'll say 6. So now let's take a look at this. We have display and our array, which is converted to a string so that we can natively show it. If we were to edit the value that we pass in, so instead of a 6-sided die, this is a 20-sided die, then the rendering would change appropriately. So far, before the display component that we've been working on, it's been hard to see how React as a framework really differentiates from writing just basic plain HTML. Everything we've got so far looks super plain, super standard, and it's basically just been kind of throwing together a few HTML tags. What really differentiates React is this syntax, which is called JSX. And that's why the file is called .tsx. If it were a JavaScript file, it'd be .jsx. .tsx is just JSX with TypeScript. What it allows us to do is we are co-locating our JavaScript code with our HTML markup. In this whole file, which technically the entire thing is JavaScript, we are able to seamlessly switch between writing HTML markup and injecting JavaScript code, which has to execute. This is the flexibility that React provides, the logic that controls how your page should render, and the markup which displays, the logic which controls how your page should render, and the markup which controls what your page should render can be controlled in the exact same spot. And in a couple lectures, we'll also show how you can include your styling also in these exact same files. But for now, we have JavaScript directly controlling what HTML is rendered, all in one file. A good example of this is how we can use the JavaScript functions that we've learned, such as the map function, to render all of our dice instead of just a single die. Let's go back to app.tsx, and instead of passing this in, let's import the sample dice from data, and then we can just say dice equals sample dice. So this is an array of multiple dice. And the way we have it currently displayed is not the best. It's just one long string, and we much prefer to kind of separate it out a little bit. So how can we render this list of dice? It's the same way that we have used the map function before. We can say dice.map, take in an individual die, and return some markup. So in this case, we can say we are going to return, for now, just a p tag, and we can say that the name is the die.name, and the size equals the die.size. We can actually shorten this like so, and check this out. We're rendering our list where we have the name of the die and the number of sides, the name, and the number of sides. And this, again, is getting dynamically rendered, dynamically created based on the dice that are passed in. Final thing is we can just add our delete close button. So to do that, we can just add a button. We can just have a big X inside of it. And because we have to return a single nested tag, we can just wrap this in an empty tag, like so. And there we go. Now we have our display and our button. However, if we want these to be all aligned in one horizontal line, like we have in the example, we can actually replace this p tag with a span tag. The difference is that a p tag automatically has a line break at the end, so it'll create a new line for our button, whereas our span tag will allow the buttons to be next to each other. And finally, if we actually make this a div instead, then our two dice will be on top of each other and ready for the next lecture for us to add the interactivity. There's just a couple more little housekeeping things we need to do, and then the final roll results component, and then we will have the entire static aspect, the static display of the dice roller finished. First off is we just need to add a roll and a clear button. So we can go to app.ts, underneath here, add a button, and we can just call it roll. And then underneath rolls, we can add a button that says clear. And then we can say roll results, like so. And then the only thing we need to add is this final roll results component. So it's important to notice that this roll results component is actually rendering a list of lists. We have the list of roll results, and then within each result, we have the list of all of the die. So when we're approaching this, there's two different ways we could create this component. If we assume that we have the data up in our app component, so we can import sample data, we have sample dice, and then we can say sample rolls, right? Sample rolls is a two-dimensional array. Each round is one index in the array, and then within that, we have the roll within the round. We could either have our roll result component implement a single round and loop through all the dice in the round, and then have our top level app component loop through each round. Or we could just pass the entire die results into the roll results component and have the roll results component handle the entire thing by itself. I'm going to opt for the former. However, you can think about how the implementation would differ a little bit for having roll results handle a two-dimensional array instead of a one-dimensional array. If you think you're able to completely implement this component yourself, I would encourage you to give it a shot off the get-go, and then if you get stuck, I'll show you how to implement it in 1 second. So first off is we need to declare what type our props are going to be. We can import the type roll result. Maybe it's not roll result, types die result, not roll result, die result. Then create the type roll result props is going to have an array of die results. So die result array. Then we can export const roll result, takes in our destructured roll results role results, which is of type role result props. And then we can create this component. Similarly to how we displayed the dice, we're just going to map through the role results. Role results.map. Each individual result, we're going to return just a paragraph for now that has the dice name, result.name, and then we're going to express it as result.result out of a possible result.size. Then we can go back to our app.tsx and loop through again, map the sample roles, say sample roles dot map. Each round will map to a role result, and the round result or role results will be that individual round. You can save that and check it out. So we've got the die and then the die name and then the actual role out of the possible number of sides. A couple other things we can do to clean this up and make it a little nicer, like we have on the finished example. One is we don't necessarily need the die name, we can just include the name, colon. But more importantly, what we want to do is think about how we can pass in the actual role index so that we can, as we're displaying this role, we can use it in our component. To do that, let's modify our role result props to also include a round number as a number. Then we also want to destructure this round number. And instead of only returning these row results, we can put this guy in curly brackets, nest it in a div, like so, and then also include that round number. So we can say round is, or we'll just put this in a little paragraph tag, round is the round number. Then in here, as we are looping through, we not only need to get the round, but also the index. And then we can say the round number equals the index. So that there we have round 0, round 1, and just delete that. Two last little challenges is we probably want the most recent round to have the highest index, and we also want to display the total dice roll. So for example, if you were rolling 2 6-sided die, you really want to have the sum of those two things. I encourage you to think about them, try it out yourself, and then I will show you my solution in 1 second. If we want to reverse the ordering, so it'll count down, say the most recent round is the highest index, and then it goes down to the lowest index. What we could do is actually pass in app.tsx. The way you can trigger this menu is just with either Control or Command P, and then you can search for a file. Sometimes makes it a little easier than finding it in the navbar. Is instead of passing in this specific index, we can instead say sample roles dot length minus this index. So this will start out at length 1, and then it'll subtract 0, and then it'll subtract 1. So if we go back, or actually, sorry, start out at length 2, and then it'll subtract 0, and then it'll subtract 1, so we'll count downwards. In order to get the total, we could do a for loop and loop through all the results and sum up a total. But there's actually one more array method that would be really useful here. It's called the reduce method. So what we can do is we can say const total equals roll results dot reduce. Now think about what it means to reduce something in the context of an array. What we're going to do is we're going to take our array and shrink it down into a single value that represents the array. So in some way, we're going to combine all the values of the array. In this case, we can just combine all of the roll result values. So combine all of these result values by summing them. But you could also imagine we could combine all the results by summing the sides, or by summing, concatenating all the names together or something like that. So we need to pass in a function which takes a previous value and a current value, and it needs to reduce down to something. So in this case, we are just adding them. We're saying previous plus current. And then what error are we getting? We need to say previous plus current dot results. And then our initial value is going to be 0 as the second argument. So our initial value is going to start at 0. It's going to be a number. And then so previous we know is going to be a number. Our TypeScript compiler is going to say that. It's going to infer it from us. And then based on this function, it's going to infer that this reduces down to a number. So it'll give us our IntelliSense to say that this is not going to error, right? If I set this as a string, then this would be all out of whack, because it would say, hey, we don't know how to combine the previous with the current, but TypeScript is very smart. It can tell, hey, we're starting with a number, and then we are going to combine a number plus a number. So we can say this is the total result. And then if we wanted to get the total sides, we could just copy and paste that. Total sides, and instead of saying dot result, say dot sides. And then we could say total is the total result over the total sides. And now we are all good. We say our total is 17 out of a possible 26 and 21 out of a possible 26. Could maybe even just add a little colon separator like that. So there you go. That is the reduce method, and that is how we can properly index our list. So there we go. We now have our entire static display ready to go, such that in the next lecture, we can actually add the interactivity and all of these event handlers to add die, roll, clear results, or delete individual dice. We created our round result component, which renders a two-dimensional list array, our dice display, which renders a single array, and our input, which just is static and does not have to take any props. But, throughout this lecture, I have had to do a lot of these indents to make our code look nice. And there's actually a couple things that I missed that I didn't bother to go deep into the weeds of explaining why you should, do this certain thing. But luckily, as a React developer, you get to benefit from the enormous total library throughout the entire web of tools that have been developed to make React development easier. And right from the start, there's one that I'm going to recommend everybody use, even at this point as you're just learning React. And there's a very good reason for it. The name of the tool is called Biome, which is two things. It is both a formatter and a linter. The formatting is pretty self-explanatory. Basically, if I am writing my code, I have all my indents out of whack, I want to just be able to hit save and have everything be nicely formatted for me. As you're developing React code or any code for the rest of this course, you really should not be wasting time making sure stuff is formatted nicely, and Biome will do it for you. The second and most important thing is it is also a linter. Linting doesn't format your code. Instead, it shows you what best practices you might be missing or what things you might be doing incorrectly. It's not necessarily going to check things that are guaranteed to error. More so, it's going to enforce that you stay within the typical React best practices so that you avoid errors down the line or avoid errors in common scenarios you may encounter. To start, you can either follow the instructions on the page for getting started, or we also have it on the website for the course. So what we need to do is we need to install the dependency. That will add it to our package.json and also copy the code directly into our node modules folder. So we can run that first line. And the second line will initialize Biome within our project. So we can close out of this and paste those two commands. So we have Biome now added as a developer dependency, and we have a new biome.json file, which is going to configure and enforce all of our styles for our project. It will, create a schema for you, but we're going to recommend that you copy and paste the schema from the 61D website. We will keep this updated, so it might not look the exact same when you watch this video, but it's going to include all sorts of things that we specifically recommend for our specific set of tools. For instance, it will use this nursery rule to actually sort some import classes. We'll talk about that later, but for now, if you want, you can leave this as is, or I'm going to recommend you copy and paste in the schema from our website. And finally, in order to actually run Biome, we're going to add this script to our package.json. So add that like so. Now let's actually use that script to format our poorly formatted row result file. And while we're at it, we'll just do all of the files within the source directory because we are going to fix everything in this source directory according to the script. So let's open up the row result file so that you can see what it's going to do, and just say bun biome. And as you can see, it beautifully formatted all of our code with the spacing so that it is so much prettier to look at. But it also gave us a bunch of errors. These aren't errors which are going to prevent our code from running. Instead, they're telling us where we aren't following all of the best practices. So for instance, let's pick an example. Missing key property on this element in iterable. And this is in our die display. So what does this mean? I am not really sure why I need a key or what a key is, but fortunately, Biome is going to tell us exactly why we need this. We can hover over and click, or command click. Why is it not doing it? Okay, we can click on here, lint correctness, use JSX key and iterable, and open it up. And then that opened in the wrong tab for me, but it'll show here. And it's going to tell us exactly what this error is and why we need to fix it. So we can read through this, and it's going to say that if an element that likely requires a key property, namely one present in an array literal or an arrow function, it's going to say that we need a key property, right? So it'll say, hey, the valid way of doing this is to include a key property when we are iterating through something, in this case, an array. And then if we want to look at it further, we can go to the React docs and go into depth. Basically, you want to have a key when you're rendering a list of things so that React can tell which item is which within that array. To do this, we can just say key equals something about the die. We could say the key is the index, and then say key equals index. But this is actually also not recommended best practice. And if you want to be able to see this right away without having to run the terminal script and get all of this output, the way to do it is to enable the Biome extension. So you can just search for Biome. If you don't have it installed, you can install it and then enable it. Then within your display, you can hover over and it'll say, avoid using the index of an array as a key in the element. The reason for doing this is that the index could change if you reorder items in the array, and we still want to be able to tell React which thing is which. So instead of using the key, we could say die.name instead. Also, if we want to get that nice auto formatting, all you need to do is do Command-Shift-P or Control-Shift-P, select Format Document, you're actually going to do Format Document With, and then select Biome as your formatter. Then I'll be writing code, and I can just hit save, and everything will be beautifully organized for me. So now, as you are coding, using Biome as a formatter will just help you code faster because you don't have to spend time fixing your tabs, fixing your spacing if you have stuff on like the same line like this. And also, it'll actually make you a better developer because it's going to tell you where you're not following the best practices and why you should follow those best practices and what you can do to actually be in line with them. So we're getting another lint error. It's saying provide an explicit type prop for your button element. I don't know why to do that. I open it up. And it's going to explicitly say why we want to do this and say what we can do to fix it. And what we can do is just add an explicit type, which basically means that for now, this isn't submitting a form, it's just a basic button that's going to do some kind of action. Now we are actually finished with today's lecture. As a recap, we showed you how you can divide a project into individual components, which can be reused or rendered as lists. So for instance, we have our list of dice. All of these components are rendered hierarchically within our app function. We talked about managing dependencies and your development environment through the package.json file. which is going to be common to all React projects and all Node.js projects. And finally, we showed how you can stay consistent with best practices using the Biome linter and also code formatter. For instance, here, we've still got a little bit of work to do. In the next lecture, we will show how to actually make our app react to user input and do something when we click all of these different buttons. Until next time, I hope you enjoyed and take care.